So hello everyone. In this lecture we are going to study application of MATLAB in control system. So in the start we will define how to calculate Laplace transform in MATLAB. So Laplace transform is can be expressed as Laplace of any time domain function can be represented as Laplace of any time domain function ft can be given as integration 0 to infinite e to the power minus st ft dt. This is the formula of Laplace, which can be easily evaluated using the Laplace command in MATLAB. Here we can find where f is the function for which we have to find the Laplace. F is the time domain function. So let's take an example. So the example we consider here is we need to find the Laplace transform of function f of t equal to e to the power minus t multiplied with 1 minus sine t. We have to find the Laplace of this particular function. So we have to use the symbolic mathematics or symbolic mathematics toolbox for defining the so let's try to code and find out its Laplace transform. So we use syms a variable t. Now we define function f equal to exp pass this minus t multiplied with 1 minus sine of t. When you hit enter, that function is stored in that f, which is exponential. Why this minus sign over here? It's okay. It convert the equation and take out minus sign from this 1 minus sine t. So there is no worry. Now we can find the Laplace transform by using Laplace command. So we take fs as a Laplace of this ft and type Laplace and passing the function f into it. When you hit enter, this is the Laplace transform of the given example. So this is the simple procedure for finding Laplace. Now you can also find inverse Laplace by simply writing you can find inverse Laplace I Laplace and passing this fs to the I Laplace function. When you hit enter, this will convert the result into time domain form. So Laplace and inverse Laplace, these two are very simple. So let's try to find out the inverse Laplace of a particular example. So let's take an example. You have to find out the inverse Laplace of first is fs is equal to 1 upon s plus 4, and second one is fs is equal to 1 upon s plus 4 e to the power minus 2s. So these are two examples which we have to solve using inverse Laplace, and we have to find out, basically we have to find out the inverse Laplace of these two functions. So first I will clear the workspace and clear the window as well. Now we define symbolic s. In that case we have defined we can define s and t both. So we can simply take fs equal to 1 upon, and in the bracket s plus 4. Now we can find out its inverse Laplace ft equal to I Laplace, and passing this function with fs, this will give you exponential of minus 4t. Actually we have to define this t variable here as it will be converted into time variable na? So we have to define the object over here t. Now the next example is we have to take f of s equal to exp minus 2 into s divided by, and in the bracket s plus 4. When you hit enter, this is the expression of fs, and now you have to find the time domain expression by using I Laplace, passing this function with f of s. This is the result in terms of Heaviside function. So I hope this Laplace and inverse Laplace is clear to you all, and how to calculate Laplace and inverse Laplace using symbolic mathematical toolbox. So next we will define the transfer function. Now the transfer function is basically denoted by TF, which is equal to CS upon RS, where CS is the Laplace of output to the Laplace of input. So we can directly assign transfer function or transfer function to a system by using a command sys equal to tf. Tf is the function which we can use and pass two vectors, that is n and d. So let's take an example. Let's take system is equal to s square plus 5s plus 6 divided by s square plus 3s plus 2. Now where n denotes the numerator vector and d denotes the denominator vector. So here n can be defined as the maximum power coefficient is 1, and then next lowest power coefficient is 5, then 6. This is n, and d can be defined as 1, 3, 2. So let's try to code this. Let's we take sys, and this will be equal to transfer function of n comma d. So we directly take n in the, and inside this transfer function and passing the value 1, 5, 6. In a similar way, we can pass the value of 1, 3, 2. When you hit enter, this will generate a continuous time transfer function, which is s square plus 5s plus 6 divided by s square plus 3s plus 2. I hope this transfer function is clear to you, and these are some of the examples which we have to to make these transfer functions. So let's try to code for the first one. First, I will wipe out the screen. Now we have to find out this transfer. We have to design this transfer function first, uh, uh, which is given like s square plus 2s plus 2 divided by s plus 1. So we can give it name tf equal to, or we can give name t1, or t1 equal to tf, and passing the matrix, that is, first one is numerator matrix, that is 1, 2 and 2. And second one is for denominator matrix, that is 1, 1. When you hit enter, this will form the transfer function t1. Now let's try to code for the second transfer function. So we take t2. So we take t2 equal to tf, and passing the numerator and denominator matrix, which is, I think, for numerator 1, 1, 1, and for denominator it is 1. When you hit enter, this will give you s plus 1 as a transfer function t2. Now we have to find the third transfer function, that is, we have to design it. So here you can see that there is an exponential term which cannot be defined using tf. So you have to use some other method for designing such transfer function in which we have dead time. Actually, this e to the power minus 2s represent dead time. So we have to use another method. Let's try to code. This will clear your this example will be solved using transfer function command itself by using a variable. Let's take a variable a equal to tf, in which we have used this. When you hit enter, this will create s that will be stored in a as a continuous time transfer function. So now it's very simple. We can define, or we can develop this transfer function directly by using a plus 3 multiplied with exp of minus 2 into s and complete divided by a plus, let's take bracket first, a plus 2. When you hit enter, I think there is some error. Oh, we have to take here a, an exponential term. So there is an error here. We have to take a, and when you hit enter, this will be your t3 transfer function. Now let's try to develop this t4. T4 is very simple, as we have mentioned, or we have assigned transfer function as to variable a. We use that variable here also. So T4 equal to, first take bracket, a to the power 2 plus 6a plus 3, this whole is multiplied with exp of minus 6s, and this complete expression is divided by s cube plus 7s plus 4. So s to the power of 3 plus 7, no, we have to take a here, no? So, and there is a mistake over here, minus 6 into a plus 7a multiplied with a plus 4. So I think this will create the transfer function fourth. Actually, this term in the transfer function third and fourth, this term and this term represent dead time. So I hope these transfer function and how to make transfer function is clear to you, and these commands. Now from transfer function we can calculate the poles and zeros by simply using tf2zp command. So for finding out zeros and poles, we need to use this command. We have to take here first z, p and k equal to tf2 zp n comma d. So here n and d is numerator and denominator of transfer function, and z is the zeros, p is the poles, and k is the gain of transfer function. So let's take an example. We have a transfer function s square plus 6s plus 3 divided by s cube plus 5s square plus 6s plus 2. So we have to first define this transfer function and then finding out its zeros and poles. So let's try to code. Here we take it as let's take t1 equal to tf and passing both the matrices of numerator and denominator. So we have first coefficient 1, 6 and 3 in numerator. I have taken 5, which is 3. Now for denominator, the coefficients are 1, 5, 6 and 5, 6 and 2. So this will give the transfer function, but we have to find out basically the zeros and poles. So we have to change this function to tf2 zp, and here we have to define z comma p comma k. When you hit enter, in z there are two zeros, which is minus 5.4495 and minus 0.8. 5505, and the similar way we have 3 poles, minus 3.4142 and minus 1 and minus 0.5858, and the gain of the transfer function k is 1. So I hope how to convert any transfer function into zeros and poles by using TF to ZP is clear to you all. Now we can convert in a similar way any any Z zero poles to and to its transfer function. For that case, for converting zero poles into transfer function, we need to know three arrays, that is zero array and pole array and then the gain of the system. So let's understand the command for ZP to TF. You have to find out this N and D, which is equal to ZP to TF and passing ZP and K. So let's consider a system. Let's consider a system having zeros and poles P1 equal to 5, P2 equal to minus 2 and P3 equal to 6, and having the gain of the system k is equal to 1. So let's try to find out the transfer function for this particular example. So we define first z equal to, so we have to take multiple rows and single column. So the first one is 0.5 and the second one is 0.3. This is the Z matrix, that is the zeros of the system, and pole matrix P is equal to 5 colon minus 2 colon 6. When you hit enter, this will give you pole matrix or array where k equal to 1. Now you can use the statement n comma d in the square bracket and finding out zp to tf and passing the values z comma p comma k. This will give you numerator matrix and denominator matrix. So you can find out simply a transfer function tf by passing n comma d. This is the transfer function for the system for which the poles and zeros are these: z1 equal to 0.5, z2 equal to 0.3, and poles are 5, minus 2 and 6, and the gain of the system is 1. So I hope these two for converting transfer function to zeros and poles and from zeros and poles to transfer function is clear to you all. So now considering the next command, which is simply we have to convert any transfer function into its state space model. So in state space we have four matrices, that is A matrix, B matrix, C and D. So we can directly convert any transfer function into its state space form. So let's study transfer function to state space. So in state space, the system can be represented by so two equations, that is x dot equal to ax plus bu, where y equal to cx plus du. Cx plus du. And the order for these matrices are, we have x, uh, which is a column vector of order n cross 1, state vector. So the vector x dot will also have n cross 1 dimension. In a similar way, u can be u can be of order m cross 1 according to the number of inputs. We can define the value of m, and where y can be of order p cross 1 and matrix A is of order n cross n and matrix B of order n cross n. Similarly, P matrix C is of order P cross n and matrix D is of order P cross n. So let's take an example. So this is the example in state space form. This is the equation for x and this is the equation for y. And now we have to use the command, that is ss, and pass the input argument a, b, c, d, that is the four matrices. This will generate the system. So let's try to code it. So we have a equal to, or we can take it capital A, equal to 1 1 1 1 colon 0 minus 1. When you hit enter, this will store A, and we have B equal to 1 colon 0 and C equal to 1 1 and D is equal to D is equal to 0. So we can define this system by using SS and passing all these matrices A, comma B, comma. I think we have taken small c, so here we use small c, comma capital D, and this will generate the continuous time state space model. Now we can convert any transfer function directly into state space by using a command that is state space to transfer function to state space. The command is we can convert any system from transfer function to its state space model. For converting the transfer function into state space, we have to use this statement a, b, c, d will be equal to tf2 ss and passing this function with n comma d, where n and d are numerator and denominator matrix of a transfer function. So we have an example tf equal to s square plus 6s plus 7 divided by s plus 4. So we have to convert this into state space. So let's try to code. So directly you can use this command which I have mentioned, a comma b comma c comma d comma c comma d should be equal to tf2ss, and passing this function with n and d vector, where n vector is 1, 6, 7 and d vector is 1, 4. So in order to there is an error. The order of denominator must be greater than or equal to order of numerator. So for converting any transfer function, there must be a condition which is that the order of the denominator should be greater than the order of numerator. So let's change the transfer function. Here we include two terms, only one term, that is s square plus s plus 4. So let's try to code for this. Now there is one value which we have to increase, that is 1 comma 114, and when you hit enter, this will convert the transfer function into its uh, state space form, that is matrix A B C D. Now we can simply convert any state space model into its transfer function form. For converting state space to transfer function, we have to use this particular command, which is n comma d should be equal to ss to tf, and passing this function with all the matrices of state space system. So let's take an example and try to code for that. So we have a system x1 dot and x2 dot should be equal to 0, 1, minus 5, minus 10, x1, x2 plus 0, 15 with u. Now y can be given as 1, 0, and both the states x1 and x2. So we have given a state space model and we have to convert it into transfer function form. So let's try to code for that. In that case, we have to take n comma d should be equal to ss to tf, and passing all the matrices. So we have to define first the matrices. So let's take a equal to, first clear the command window and then clear the workspace, and then define a equal to 0, 1, minus 5, minus 10, and b equal to 0 colon 15, and the similar way C equal to 1 comma 10, and D equal to directly 0. So now we can use this command n comma D should be equal to SS to TF, and then passing all the four matrices A comma B comma uh, C comma D, and when you hit enter, this will give you N and D matrix. So N contain only K constant of the system, and denominator will contain 1, 10 and 5. And if you want to convert this into the transfer function form, you can simply type TF. You can simply type TF and passing these two N and D will give you a continuous time system, that is 15 upon S square plus 10s plus 5. So I hope all this command, that is converting uh, any state space system to transfer function or any transfer function to state space, is clear to you all. So let's try one more example in which we have to convert a particular transfer function into its state space form. So in the first example, we have to convert this transfer function into state space, and in the second example, we have to convert this state space model into its transfer function. So let's try to code for the first one. That is, we have to convert this transfer function into its state space form. So we have to find A comma B comma C comma D, which should be equal to TF to SS, and passing the matrix N and D. N matrix is 1, 6, and the D matrix is 1, 7, 4. When you hit enter, this will give you all the four matrices A, B, C, D, and you can define now system equal to SS and passing all these four matrices A, B, A comma B comma C comma D. When you hit enter, this will create an continuous time state space model. Now in the second example, we have to convert this particular state space model into its transfer function form. So you have to first assign all the matrices, that is A, B, C, D. So first wipe out the workspace by typing clear command and clear the command window also by using CLC. Now you have to define first all the matrices. Let's take A equal to 0, 3, colon 1, 2. This is store A, and B matrix equal to 0, colon 1. The similar way C matrix equal to 1, 1, and D matrix equal to 0. Now you can convert this directly into its transfer function form by simply putting n comma d should be equal to ss to tf and passing all the matrices, that is a comma b, a comma b comma c comma d. When you hit enter, this will give you n and d uh, arrays, so you can simply make system by using tf command and passing the input argument, that is n comma b. This will be the continuous time transfer function of the system. So I hope uh, this application in control system, application of MATLAB in control system, the basics will be clear to you all. I think we have covered different commands. That is, first we have converted any time domain signal into its Laplace form. Then we have seen inverse Laplace, and then we have covered the transfer function model or the transfer function of the system, then converting it into zeros and poles, and from zeros and poles to its transfer function, then state space representation of system, then converting any state space into transfer function, and from transfer function to its state space, which we have covered so far in this lecture. So thank you very much.